Well, welcome everybody. Thank you for joining us today. It's a little after 2 p.m. I know we're having a little trouble with a couple of our panelists signing on, but I wanted to go ahead and get this rolling with the three panelists we had currently here in the room. I want to go over our agenda real quick. From about 2 to 2:15, we plan on doing a little bit of welcome, going over the agenda and some introductions from our panelists. Then we will get into a little bit of background on why we're here, some of the things we're going to discuss, and then we'll get into the roundtable discussion with our panelists. We'll be asking them some very specific questions and hopefully some valuable information, and that will happen um, from about 2:20 to about 3 p.m. And then from 3 to 3:30 p.m., we're going to do a little Q&A where everybody in the audience can utilize their chat function and ask questions. I'm going to ask Jim Sika to please see if he can monitor that for us and help us do that. He's also with the International Code Council. So we are here today discussing cross-connection control, backflow prevention, a key component in protecting our potable water system as part of Building Safety Month, week 4 uh, for today. So I see Mitch got on now, so that's great. I want to let everybody know also that we will be recording today's webinar for reuse later on, and we're going to do everything we can do to make this a very productive day. So please, panelists, just speak up if you got something to say. We would love to hear from everybody. Now, my name is Rich Anderson. I am one of the directors of PMG Technical Resources with the International Code Council. Also in attendance from the International Code Council is our co-host, Jim Sika. Jim, I don't know if you're still trying to help Octavio sign on or if you can say a couple of words. He's probably still helping one of our panelists try to log on. So let's go through introductions from the panelists. And I'm just going to go around my screen the way you're showing up. So Bruce, would you like to introduce yourself, a little bit of your background and why you feel it's a value to be here today?
Absolutely. My name is Bruce Rathburn. I have a small company, American Backflow H2O. The history behind me is 35 years in backflow prevention and cross-connection control within the state of Texas. I'm also on the cross-connection control work group for the state of Texas, and I was international president for ABPA and served on executive committee for 13 years.
Great. Thanks for coming, Bruce. Now, the next person showing up on my screen is Mark Nguyen. So welcome, Mark. And Mark is also with ICC, but he's one of our panelists today. So thanks for joining us, Mark.
You bet. Yes, I'm Mark Nguyen. I am the Director of Plumbing and Backflow Education for ICC/Nguyen CE. We are the education wing, newly joined with ICC. I'm talking to you from Texas. I live in West Texas, but obviously we kind of reach all over the place. My background is for over 35 years now, I guess 37. I've been a licensed master plumber for the last 12 years or so, maybe even longer than that, 15. This has been on education. We owned and operated Nguyen's Continuing Career Education that my parents started. We, in the last 5 years, we've out into also providing education for backflow. Currently, I'm the not only the director of backflow education, I'm also the approved provider, approved instructor through TCEQ for us to be able to do those. So it's a pleasure to be here and a lot for us to talk about and see. in the area of backflow. Thank you, Rich.
Thanks, Mark. Appreciate it. Next up is Bill. Bill, would you like to do a little introduction, sir? You are muted.
Excuse me for that. My name is Bill Cirillo. I'm from Indianapolis, and I was a plumber for 50 years before I retired. I've been involved with code and licensure issues in Indiana, and also do a lot of teaching, and I kind of in the administrative capacity of of an apprentice school here in Indianapolis. Been involved with backflow and backflow testing since probably the early 90s.
Excellent. Thanks for coming, Bill. And last up, that's in the room right now. We're still waiting on a couple to try to log in. But Mitch, would you like to introduce yourself and give us a little background on yourself, sir?
Yes, good afternoon. My name is Mitch Labat, and I live in Baton Rouge, Louisiana, and I am a licensed civil engineer in the state of Louisiana. In 2002, I got into the backflow arena, and since then, we have evolved into a training organization here in the state of Louisiana. We also have done work in or are doing work in the state of North Dakota and have provided some training in Oklahoma and other opportunities around the country. And we also offer consulting services. We are the lead consultant for the Sewage and Water Board of New Orleans as we are preparing and implementing and developing their cross connection control program. We have also assisted over 30 separate water systems with the development and implementation of their program. We have certainly learned from the School of Hard Knocks. So the other component from a credential standpoint, I guess, is I personally am a member of the National AWWA Cross Connection Control Committee and am serving as the committee chair for the revision of the M14 manual that we are hoping will be in production by the end of the year. In addition to that, we have developed software applications to manage programs. Our training is focused more from a consultant standpoint, and we, in essence, teach our consulting work to others. So I guess that's a pretty good synopsis at this stage. So thank you for having me.
Thanks for coming, Mitch. I appreciate it. So as an overview today, we're going to have a 3-panel part discussions. I just heard from Joe Montoya too. He is stuck in a work meeting as we all work for a living. So he sends his apologies that he will not be coming. And we're still waiting to see if Octavio from Boston, Massachusetts can get logged in. I think Jim's still trying to help him out with that. So moving on. Part 1, we're going to discuss kind of choosing the proper cross connection control, either a device or assembly, talking a little bit about the differences between the assemblies and devices. We want to talk a little bit about, what's back siphonage, what's back pressure, identify high hazards, low hazards, and how understanding the differences helps us choose the proper method, device, or assembly. So my first question for the panel today is going to be, can you guys kind of describe in your own words the difference between back pressure and back siphonage for everybody in our audience? Somebody just jump in. Bruce, you're muted.
Going ahead and kind of give you a simple analogy. Everybody that's sitting around the table is subject matter expert as far as what's going on within the backflow prevention world. And I got caught up in a council meeting one time and trying to explain to people that have no clue what back siphonage or back pressure is. I thought something quite simple, and they seemed to grasp what I was talking about. But if you'll just take a cup and a straw, and you've got it in a cup of water, if you're creating back pressure, it's something as simple as a child would be blowing through the straw to create the bubbles for entertainment. When you talk about back siphonage, that's when somebody's actually drinking through the straw and drawing liquid into your mouth. So that seemed to kind of give them a very simple understanding of what those two processes are.
Excellent.
Rich, the only thing I would add, and that's a great analogy, and I mean, I liken it to that back siphonage is pulling water in its unintended direction, where back pressure is pushing it in its unintended, undesigned direction. We use those terms an awful lot: back siphonage, back pressure, and back. But it's simply one direction is something from the service side is pulling water. On the other, you've got something in the outlet side pushing water back in the wrong direction.
Great.
This is Mitch. I would add on top of these two really excellent examples is that for our listening audience, I like to look at the real world application where I explain that the main water line at the road is coming in at 60 psi of pressure, and a fixture internal to a facility may have water at 20. If the 60 falls below the 20, in its simplest terms, through a waterline break, then the 20 exceeds the atmospheric pressure. I refer to it in my language as as the big ones eat the little ones. It's always going to go high to low pressure. So 60 is pushing towards the 20 internal to the building. If the 60 drops to 0 through a broken water line, then the 20 will back siphon back towards the 0. That would be a back pressure example, a back siphonage example. Back pressure would be the 60-20. If I took the 20 and elevated it to 120 through maybe the use of a pump, then the 120, the big ones eat the little ones, 120 is going back to 60. So that would be a very simple, practical explanation. Thank you.
Bill, do you have anything you want to add to that?
No, I don't think so, other than pressures can be generated in a number of ways within a building to cause backflow. And it could be something as simple as heating water would cause a increase in pressure from the building side to the service side.
Mm-hmm. So when we're talking backflow prevention and cross connection control, why is it so important to understand the differences between back siphonage and back pressure, gentlemen?
It's just device selection. That's what it amounts to.
Well said.
That was a quick and easy one, right? Um, so as we start, and I think we already did it. A couple of you gave some really excellent examples. Bruce, I actually liked your straw analogy. I hadn't heard that one before. That was a really excellent way to see what we can do and draw that analogy. So, are there any other examples of, either something that you've seen in your career that has caused back pressure or back siphonage, and without divulging locations and what it was, just a quick overview on some of the common things you see in the field that create those scenarios.
I'll give you one pretty quickly that I think all will agree to. If you look at all of the information that's out there available, it always seems to go back to a garden hose. So if you want a quick analogy to something like that, I had a situation where a lady was doing something around the house, decided she was thirsty, went to go get some ice cubes out of her refrigerator. And in this end, instead of from the garden hose, it originated from the toilet in the house. She couldn't understand why her ice cubes were blue. And it wasn't that she was preparing for a luau, it was due to the fact that she had a loss of water pressure, like Mitch was talking about on the water main, and it caused it to siphon everything out of her internal plumbing fixtures. And that being the case, the colored water that came from the toilet ended up changing the ice cubes. So trying to explain that to people is the reason why I came up with the straw analogy of back siphonage. And she seemed to grasp that pretty well of exactly what happened. She did the right thing, obviously, and dumped all that down the sink and waited till things got cleared up after the main break, and then I followed up with her after that. But it can just happen so simply with any type of change within the distribution system.
So Bruce, you mentioned that was siphoned out of the toilet tank.
Correct.
When you furthered your investigation, was there an improper installation of a fill valve or
That's
an
correct.
improper fill valve? What was it?
Well, it was improper fill valve due to the fact it had no anti-siphon capability. And it was in an older home. And she got together with the local plumber that she used. And at that point, they went back in with the proper fill valve with some type of anti-siphon. But that was, a resolve for her in that particular end. Of course, they're still out there, and somehow people are still able to get those fill valves that do not have anti-siphon.
Great. Any of the other panelists want to provide any examples of either back siphonage or back pressure they've come across?
Yeah, Mitch here. I will kind of touch on something that Bill brought up just one sentence here a few minutes ago about the causes of backflow. I ran across, in its simplest form for our audience here, a situation one time where the supply line to a drink dispensing machine, where you can get your beverage of choice inside of a restaurant, the supply line to the syrups, there was a backflow preventer, an RP, further up line. But prior to the backflow preventer, there was a tap on that supply line to provide yet another water supply line to a separate drink dispensing machine that was, say, behind the restaurant itself. So to set it up, we had a drink dispensing machine behind the main wall in the kitchen area, and we had another one that was inside of the restaurant. Same water supply that teed off to supply the water to both. Well, what was interesting is the uh, supply line to the drink dispensing machine in the kitchen area. When the servers would get the customer's drink and bring it out, as they were taking water, they were, because of undersized lines, and it's on the heel of what Bill was talking about earlier, there are many causes of pressure changes, which is actually what initiates the backflow. When water was, or when a drink was taken out of the kitchen machine, it would actually dispense water into the restaurant where the backflow preventer was. So in other words, there was a draw of significance instantaneously prior to the backflow preventer, and it would cause that relief valve to temporarily open. So I was trying to piggyback on Bill's earlier comments of numerous causes of backflow that can happen. I thought I'd share that.
Thanks. You bring up an interesting scenario, Mitch. You know, we drink the final product out of those beverage machines. Why is it so important to have cross connection control on them?
Well, you know, my thoughts, and I guess there's, you know, an opinion on all, but you know, there are, if you go back and look at these drink dispenser machines, typically you will see where the customer can select only water. Normally that's connected to something like the pink lemonade or the high C or whatever that drink is. I would challenge our listening audience to go get some water and see if that water is actually clear. So why is it an issue? You know, for someone who may be suffering with diabetes, who has to watch sugar intake, things of that nature, you know, that drink could be um, detrimental to their health if some of those syrups and sugars get into what they are assuming to be pure water. So there's some risk and potential health issues associated with something as simple as a drink dispenser machine.
Great.
Can I jump in here a second, please?
Go ahead, Bill.
There's also the big issue with those soft drink machines is they have carbonation gas in it. When that hits copper downstream of it, it causes problems. I did a lot of restaurant work in my life. I mean, there was a time when my company was working at, you know, 10 or 12 restaurants a day, and I bet at least a dozen times I get a call and say, we got air in the water lines. And they get to the point where I could diagnose the problem over the phone. It was the carbonation gas because of a backflow preventer failure, or it was the water softener regenerating, had a little problem with that. So pretty much narrowed it down too before I ever went there. But it is a problem when the carbonation gas gets back into the water piping system.
Well, Bill, if you mentioned that when that CO2 that we use to carbonate those drink machines comes in contact with the copper, you said that that's not good. What does it create, and why are we concerned with that? I'm just going off, what you said.
It leaches copper out of the pipe itself and then creates like a copper sulfate, which can make people sick. I don't know if I've ever heard anybody dying from it, but it can make you pretty sick for a while.
Great, thanks. Um, Octavio, I hope I'm pronouncing your name right. I'm so glad you were able to get in.
Yes.
I'm sorry for the technical difficulties you had, but if you'd like to go ahead and introduce yourself to everybody right now and kind of what your role is and the importance of cross-connection control in your world.
Sure. My name is Otávio de Paula Santos. I work for DEP, Massachusetts Department of Environmental Protection, and the Drinking Water Program. I'm in charge of the cross-connection control program for the state of Massachusetts. I work for the agency since 1999. I work for the cross-connection control program since 93. And the state have a cross-connection control program since 1937. When the drinking water program was part of the Department of Public Health. The first document, the directive regarding cross connection was basically 1 page long. So later on, during 1970s, the state created the Department of Environmental Quality Engineering, and then the drinking water program moved to the newly created agency, where we stay until today. The name changed to Department of Environmental Protection, and we have a very active program, and I'm very pleased and honored to be part of that.
Great. So, Octavio, one of the roundtable discussion has progressed a little bit, and what we're discussing now is just maybe some examples of either back pressure or back siphonage that you've ran across in your career, and maybe what was the health hazard associated with that, and possibly the remedy. Do you have any examples you'd like to provide for everybody?
Well, yes. Well, first of all, it is not back pressure and back siphonage is not what creates cross connection. Cross connection, it is a plumbing issue, the plumbing situation, which then allowed the water to reverse its flow, its normal flow, which in all the cases should be from the distribution system, from the water main up to the last free-flowing tap of the customer. So when there is a piping connection, piping situation, and if there is a drop on the supply pressure, then that one is what causes the back siphonage. On the other hand, if there is an increase of pressure on the customer side, that one also causes the water to reverse its flow, and then in that case it comes from the customer to the supply line. So, and all of that, of course, can bring a lot of issues. We all know that the water main, it is not 100% tight. There are cracks in the joints, and that one, what is important, the systems to maintain a positive pressure to avoid any infiltration of the liquids or even gases that come in contact with the potable water line.
Thank you. Mark, did you have anything you wanted to add? Maybe an example or something?
Well, I mean, over the years in plumbing, we've come across a lot of things. You know, it's the dispensing machines is one of the ones that gets a lot of questions, and that's kind of why I wasn't chirping in. I think that's probably one of the biggest misconceptions, you know, about why we need one or why we don't need one. When you get into the commercial realm, just like Octavia was saying, you know, we've got, it's the cross connection that's the problem. Connect to the what I call in my classes, I call the backflow incident triangle, much like the fire triangle. You've got to have three things present for there to be a backflow incident, just like you got to have three components for there to be a fire. If you can remove one of those,
correct,
then you're gonna eliminate that incident. Some of those, for example, as I was starting to say, like in commercial, when you've got pump systems, you've got, you know, recirculating pumps. A big one, I guess, would be a boilers, where you've got the filler lines for those. You actually pipe in what we call a backflow connection piping arrangement. You actually pipe it that way because it needs to have that water, that refill water. But just, I think it was Bill mentioned a lot of things that can cause that back pressure, and thermal expansion and heat is one of those things. So
correct,
almost every one of the instances we could go around talking about, but if you can remove one part of that triangle, then that's really what backflow protection or backflow control is about, is eliminating one of those, either the cross connection, the hazard, or hydraulic condition with backflow back siphonage to create backflow. So I like I say, that's one instance that I can think of top of my head, but I was enjoying listening to their explanations of it, really.
Thanks, Mark. Another one that comes to mind, and I don't know if anybody wants to touch on it, but I've always been an advocate for like hose bib cross connection control on houses or silcocks. Anybody want to elaborate on the importance of vacuum breakers on hose bibs and keep them off pressure 12 hours in a 24-hour period? You know, maybe those little Y devices we see sold at the store, even on mop sink faucets in commercial, right? It's the same concept. So would anybody like to kind of take that one and run with it?
Yes.
Go ahead.
Okay. Okay. Thank you. Yes, cross connection happen everywhere. In Massachusetts, what we do have it's the all non-residential facilities are required to be surveyed for cross connection. All the water department systems are required to survey those facilities for cross connection, and they should eliminate as much as possible with the creation of air gap separation or properly protected. When we say properly protected, we target most of the use of RP device and double check valve. This because of the plumbers in their exercise of their profession, they do require other type of non-testable devices. So that one is one side. And for the residential facilities, we do have an educational program that all water system must develop it, and they have literature and meetings at the local level, and involve other departments and the municipal arena. So the department or the board of health is important, the fire department it is important, the plumbing department it is important, the building department it is important, and the water supplier are not alone on this, on the protection of the potable water. Everybody it is responsible. Start with the owner of the facility that must notify the water department if there is any change in the plumbing system in that facility. The installation of a new equipment which require water for cooling or other purpose. So that one, it is everybody is responsible for that. So it's sometimes it's the water suppliers feel overloaded with the responsibilities, and of course that one should be emphasized to the customers that they are the ultimate responsible, and the residential owner, they should know about how cross connection occurs and should avoid to create the cross connection. A lot of water departments or districts, they do provide one hose bib for service connection, residential service connection. And of course, they have a list of plumbing supply stores around their town or the neighborhood community where they can purchase other hose bibs for the thread outdoor outlet. So that one is definitely the starting point, is to have our thread outlets properly protected.
Great. Bruce, I think you were going to try to say something there for a minute too. Would you like to jump in?
The only thing I would like to add, and that was a good overview of exactly what it's all about and what we're trying to do to protect the end user. Ultimately, it is their knowledge of realizing how a hose bib vacuum breaker works. I did numerous water use surveys, Mitch and I've worked on a number of surveys together, and it's interesting as something as simple as hose bib vacuum breaker just trying to get them to grasp that concept, how simple it is, but yet how effective it is if it's used in the proper way. The thing that seems to always impede a bit is you get someone that comes in and they need to use the water for something else. And I'll give an example of the pool fill guys. You know, they
Yeah.
have a ready way of going at hard piping to that hose bib and that vacuum breaker, and then they leave that water on all the time to facilitate that pool fill. Well, at that point, your vacuum breaker's gone, and now you're virtually counting on a semi-submersible fill line to that pool. But if it's used in a proper way, it's an amazing what an effective device it is to stop backflow.
Correct. Because there is may I add something? To have a device like a hose bib, even if it is not the really proper device for that situation, at least nobody can say that you're being negligent. The judge we're going to consider that you try to use it something to avoid a backflow incident. So that one is also important. There's the liability issue that everybody have to consider these days.
So moving on to our next question, can we kind of discuss some of the terminology we use and what some of the differences is? Because sometimes when you just look up a word in English like pollutant and contaminant, they're kind of, they mean the same thing, but in the world of cross connection control, right, we associate one with a high hazard and a low hazard. So would anyone like to take those two definitions and try to explain them to our audience and why they're important and to understand those terms? And maybe an example of a low hazard or a high hazard.
So this is.
Go ahead, Mitch.
Oh, okay. I'm sorry. So my explanation of the pollutant versus the contaminant is, and when I'm speaking to, depending on the audience, I like to refer to the pollutant and contaminant situation. I'll go back to our drink dispenser machines. The syrups would be considered as a pollutant, which in typically are not detrimental to the public health. So my conversations to the audiences are, all right, let's say you're going to stop and you know, one of the local chains and get the burger, fries, and a drink. You go get your drink. The minute you hit the actuator, you're connecting water and the syrup. The syrup, of course, is something, is my terminology is, if it can go, you would not be opposed to it going in your body, then it would be a pollutant. So that would be the syrup. So when you finish that meal, you get in your truck and you ride down to the car wash and shove the quarters in, then you get to choose, you know, wash, wax, tire cleaner, whatever it is at the local car wash. And then once you hit the wand to spray the water, in essence, that's the equivalent of hitting the actuator at the restaurant. And the only difference is, instead of getting, you know, orange, Dr. Pepper, Coke, or whatever your product of choice is at the restaurant, which would be the pollutant, now you have the potential to bring into your body tire cleaner, wash, wax, and that, of course, would be the contaminant, which can cause disease, sickness, or even death. So it's a little bit of a long explanation, but usually the audience gets it. Bottom line is, in the way I speak it, is pollutant is something that's not water that you can put into your body. Whereas if the contaminant, of course, would be something much more detrimental. So hopefully our listening audience today can understand the differences between the pollutant and the contaminant. Of course, that is one piece of the information that is required to determine the appropriate level of backflow prevention.
Excellent answer. Does anybody have anything they'd like to add?
I just like to say that a pollutant is more aesthetic, so which it is different from contamination, which can be chemical, physical, biological, radiological, which definitely is detrimental to the public health. So the aesthetic, it's the color, odor, something like that. So it's definitely that one. Nobody wants that, but at least it is more manageable than really does not affect the health. Of course, you're not gonna use a polluted water to a dialysis machine. So it's try to avoid as much as possible to provide to the patient to the best quality of water. In our regulation in Massachusetts, the very first item in our regulation is the purpose. And we state, and this was for many, many years, that the water supplier is responsible for the quality of the water from the source to the last free-flowing tap. So that one creates a big issue years ago with the plumbing inspectors. Plumbing inspectors is really say, no, after the meter is my responsibility. Well, not really. We share responsibility with the water supplier to protect the users. Massachusetts has an implant type of protection, of cross-connection control program. We protected the users. And we have in our regulation a list of facilities that must have a redundancy, because if it poses a very high health risk, we do have a containment device at the meter, which it is an RP device. So, but in the other cases, we try to have the implant protection. Also, is the idea to have dedicated lines for fire protection system in non-residential facilities, for example, dedicated line for underground irrigation system, to avoid to use the domestic line, which should be the primary to use it for human consumption, basically, and animals also. So everybody wants to use it to tap in our drinking water. And of course, it's getting very expensive to produce a high quality of water, but we're still flushing our waste with potable water. We still fight fire with potable water. This you're going to have to change, I think, in the future. We should have a third party in the street for reused water, rainwater, whatever.
Octavio, I can't do anything but applaud that, and that when we have a water reuse webinar, we can definitely address that one. So I'm going to move on to our next question, though, just because you guys are giving some great answers, and I want to give the audience what they came here for too. So once again, talking about terminology and what we use, we've mentioned the word device, and we mentioned the word assembly a few times. Would somebody like to maybe take a crack at the difference in the two, which ones can be tested and inspected? What's the difference between testing and inspections? And why is it important to know the difference? Don't everybody speak up at once. Go ahead, Bill.
I'll take a stab at this. It started off to be something kind of different because an assembly was really a device that was made up of components, would be inlet, outlet valve, test ports, etc. But I think the main thing is they had that USC Cross Connection Foundation approval on it. But I think we gotten to the point now, it really doesn't matter. I mean, whether you call it a device or you better call it assembly, I really don't think it makes any difference. You've kind of got three layers or three things to satisfy when you choose a device, you know, or three authorities. So you got a plumbing code issue, you've got your state in Indiana, it's IDEM, Indiana Department of Environment Management, and the water utility. And sometimes the State Department or water utility might have a list of approved devices, even though there'd be 100 devices that have the same ASSE approval, they may not be on that list. So even manufacturers sometimes misuse those words of device and assembly. An example is I looked up a device from one of the major manufacturers. It was a dual check with an intermediate vent, and they advertise it or list it as a backflow assembly. Well, I don't think it meets the original definition, but again, who cares? If the device is appropriate for the application and it satisfies all the people who might need to be satisfied, the authorities, then it really doesn't matter.
Rich, if I can add to what Bill's saying, and I agree, it's one of those things that if it's approved for that usage, then. But I try to keep them separated with just something very simple. An assembly is something that's got test ports on it that we can put a differential gauge on, and we can test to see if the components are working. A device may, again like the one that Bill mentioned, I mean it works fine, but we have no way of putting our differential gauges on them, being that just piping arrangement, which would be a air gap. So we've got those three kinds, and to try to get our heads around why we call which ones we call, all of us probably wind up calling them the wrong thing a lot of times just because of which we get talking about them. But the assemblies pretty much have to have a means for us to connect our test gauge, our field test gauge kit to our different devices. May not have that ability to gauge some other test to find out if it's working or not. And then the air gap, which a lot of people just kind of tend to blow off and say, oh, well, it's, there's no way to test it. Well, yeah, there is. You move your hand. If there's a free space there for it to do what it needs to do.
Excuse me. I heard once about the difference between device and assembly is that the assembly, it is devices that do require to have a shut-off valve. So you have an RPBP, you must have the shut-off valve downstream and upstream. And usually devices, in most of the situations, don't need to have a shut-off valve, like a residential dual check, for example, or a dual check intermediate vent. Sometimes, depend of the location, it's wise to have it for maintenance or even for replace that device, because non-testable devices also has a lifespan. Manufacturers say it's between 5 to 10 years. You must replace a check because they're movable parts and they're rubbers and the discs, etc. So that one is what it differentiates one and the other.
Without us getting into going over all the different types of devices, like, just real quick off the top of my head, like an ASSE 1022 or an RP or an RP detector device, just in your own words, how important is it to make sure that we're properly assessing the hazard, whether it's a pollutant or a contaminant. And then based on the listings of those devices or assemblies, choosing the proper one for the proper application. And what are the hazards associated if for some reason the wrong assembly or device is chosen?
It kind of goes back to really what Mark started out with initially when we were having a discussion about back pressure and back siphonage. Of the assemblies that are testable assemblies, that's what's going to become key, is first looking at the aspect of it. Well, is it going to be subject to back pressure or back siphonage by anything that's going on internally? Then secondly, the other thing we discussed as far as pollutant or contaminant, whatever's downstream of that backflow preventer, is it going to be something that could pollute the water system, or is it something that could contaminate the water system? Then from those two pieces really allow you to kind of move forward of choosing the right assembly in that application. You brought up about the 1022. The 1022 is promoted to use in a carbonator, actually. We've got that in ICC code. However, it will always be of question is it working? Is it working? So if you have that in an enclosed area and you subject somebody to CO2, and just a simple Google on CO2, if you're in a closed area, that could be very detrimental to somebody if that vented to atmosphere. Could be the same thing with an RP also. However, the RP will give you indicators it has a problem. And in most cases, a device won't until something happens.
Mitch, Bill, Mark?
Yeah, that's a great point. I as he was talking, I was thinking that when you're talking about which one you're going to choose and what could be the problem, if you have a double check where it really should be an RP or something else, if it's not functioning right, you don't know unless you've tested it, because it has no outward indication until you get the problem, coming out of the faucets or wherever. And so, that the other ones, I liken them to, they kind of have a safety valves on them. They've got a relief port opening, or they've got air inlets to where you have some indication they're spitting out water or they're pulling in air or doing something. But like a double check, you just don't know unless you put gauges on it to see and run it through the test and see if it's functioning correctly. So I appreciate what he says. There's key things that you got to decide. And if you get the wrong choice, you may not know that it's not doing what it's supposed to be doing until there's already a problem with a contaminant, especially. Pollutant to some degree, I guess, but mostly I think of it in the sense of the contamination of a contaminant that's going to cause a health issue. You're not going to know until health issues start popping up if you've got the wrong device in there.
Thanks, Mark. Interest of time, I'm going to move on to part 2 of our discussion, just because I do want to hit some of this stuff, and it's getting close to the 3 o'clock hour. So we've touched on it a little bit already. Let's talk about testing of assemblies, and it's going to be a multi-part question. Why is it important to test? What requirements do you have for verifying testers are properly trained? And what about testing documentation? How do you guys see keeping the records, retention for those cross-connection control programs, and the importance of that? So, Octavio, I mean, I know you run a statewide program. Do you want to take a shot at that one first?
Yes, well, definitely. After the surveying of the facility, all the recommendation requirements to have a backflow preventer testable one, because as I said, that we concentrate most with the non-residential facilities primarily. The testing it is important. We do have a testing program, was the first one, and Massachusetts required the backflow preventer testers to be certified by the state, as well as the cross-connection surveys. So we do have a certification program. We use it a third party. In our case here in the New England, we have the New England Water Works Association, which does provide the trainings in backflow preventer test, as well as the cross-connection surveying. So our testers, we use it to have an official form to report the test result. And also we do have a form for, in the event of the test, the device fail the test, we have the repair and retest form. So it's today, because most of the department water systems do use a type of cross-connection control program management software, we eliminated that official form, and we accepted the whatever the systems do use it for that purpose. So it's our tests are, we do require the 2 tests a year for the RP devices and once a year for the double check valves. For the pressure vacuum breakers and spill resistant pressure vacuum breakers, we strongly recommended that they be tested at least once a year. Usually the pressure vacuum breaker is usually in underground irrigation system. And so that one, that basically the water department passed that responsibility to the owners of the homeowners to have the device test and report to the systems, because they are overwhelmed with the test. Some of the systems, of course, are more than others because of the number of devices that they have to test every year.
Great. Bruce,
This-
Mitch, Mark, any of you guys want to, or Bill,
Yes,
take what
this
you
is
see in your
Mitch.
states?
Mitch, this is Mitch here. I'd like to add on to that. What we, as a consulting company, we 100% manage 5 separate water system backflow prevention programs. And one of our requirements is that we continuously vet our plumbers and testers, in that we keep track of their certifications from whatever entity that may be. And we also keep track of their test kit calibrations, which is a requirement that they be calibrated once a year. And for some of our clients, they require insurance just for liability reasons. But the bottom line is we manage and track and vet our plumbers and testers. Actually, we look at it on a weekly basis. And we keep track of all of that in our own software. We have used various applications. Historically, we've been doing this for 20 plus years. And we just created our own because it's more comprehensive than what's out there. So it makes it easy for us to do that. The other issue or item that we've added to that in recent years is we require our approved plumbers and testers to simply log in and input the test results. And that way it's date and time stamped, and all of the administrative component of trying to get a plumber or a tester to submit a test report to the administrative team, and they turn around and input it in. There's a lot of potential human error right there, and then the finger pointing, all of that goes away when we approve through the vetting process plumbers and testers. Just because the state says that you're legal to perform a test, that approval from a state agency may be good for a complete calendar year, such as 2022. However, if their certification expires in May or June, there's still a 6 or 7 month period that, according to a state agency, that individual can test backflow preventers. Whereas in the systems that we manage, that is not the case. So we vet those plumbers and testers for record keeping to make sure they are, quote, legal.
Mhm.
And then we have them log in, and it's about accountability. There's no more. The paperwork's, they log in. They have a username ID. They input the data, and that's it. So
Mitch,
that
I don't
brings
know.
up accountability.
Yeah. Hey, Bill, do you want to maybe mention what you're seeing there in Illinois and what they're doing statewide? Just a quick overview, maybe.
In Indiana.
Indiana, I'm sorry.
Yeah.
It's too many states.
Well, in Indiana, the Indiana Department of Environmental Management, requires you to go through a course, get your backflow tester certification. We're kind of funny in this thing that if the backflow device is actually in a building, just because you have a tester certification, you can't install a device in a building. That's a plumber. Unless you're a licensed plumber, you can't install it. Likewise, the licensed plumber, unless he has the backflow testing certification, he can't test it every year and submit the test results. So it kind of gets confusing. But that happens, and it varies. I'm sure it's different in almost every state, in almost every locality, But in Indiana, we have a statewide plumbing license, but and also our backflow certification that's statewide also.
Surprisingly, Bill, that reminds me of my time working in Texas in my past. And Bruce, Mark, do you want to maybe discuss real high level how that mirrors what you guys see from TCEQ, what Bill just discussed?
Well, from TCEQ perspective, and Mark can probably speak just as well as I can to it, from TCEQ, as far as the regulatory aspects of it, they really count on the water purveyor doing what they're supposed to do within the realm of making sure what testers are doing specific in their area. As Mitch mentioned, pretty much a lot of it in and around our area is all went electronic. So now there's not that much paper pushing anymore with the test reports and so forth. But from the state's perspective, they really put a lot of that on the water purveyor. They one thing that they do here in Texas is it is held as a license in lieu of a certification. So that's different than some of the other states. You do have to go through your normal processes of taking the exam, going through the 40-hour course. TCEQ then sets you up to do your study your practical, or you test through the 4 assemblies, your actual written exam. They assign the potential BPAT, if you will, to go and get all of his testing done at a facility like a college and so forth. But as far as the tracking of the testers, all that's really on the onus of the water purveyor.
Great. Mark, I'm going to kind of cut you off and move on to the part 3 question. Properly maintained assemblies and properly maintained These properly maintained assemblies are paramount in protecting our potable water. All of these assemblies have intricate parts that are specific to the assembly. To ensure proper function, they must be maintained in accordance with the manufacturer's listing and labeling. Just somebody discuss how important it is to make sure we're using, you know, if you have a 6-inch, RP, why can't I just go buy any OS&Y valve and slap it on if my number one shutoff valve isn't working? Why is it so important to understand, you know, putting the proper number one check in the valve and, not putting a number one check in the number two slot in a reduced pressure principle backflow prevention assembly device? Does somebody just want to take high level on that and making sure we're doing those properly? Bill, you were smiling. You want to try
I'm just a happy guy naturally.
it?
No, it makes a difference. The problem is once you change and you stray from the OEM parts, you're now a manufacturer. So, and that puts you in a position where you're going to have to go get your approvals and all that. If you say you change the outlet valve, for instance, on a 6-inch device, and you just buy a regular, um, or compatible, does it really make a difference that you bid? No, it doesn't, except for the fact that now you're the manufacturer of the job, and then the assembly was made to a certain approval, and they use certain types of parts, and that's the end of the story. So after that, you kind of put yourself in a position where if there's an issue, could you be on the hook for some liability? And most of the time, it's really not worth it. Just go ahead and buy an OEM part and be done with it. And you're right, on a 6-inch valve, we wouldn't be changing the whole daggone valve just because the inlet or the outlet was bad. We'd be changing a component of it without a doubt. That's a pretty expensive piece of equipment.
So,
We have
Tavio, you kind of mentioned that you had like a form for the rebuilders. Is that something you verify that they're using OEM parts?
No, it's just for the repair and retest. First, we'd like to know who did the repair and what type of repair was done in the device.
Mm-hmm.
So, but what's happened, most of the plumbing companies, they don't want to spend time in repairing the device. What they usually do, they replace the whole device. So when the tester come to retest the device because those fail, and that one that we have 14 days for the device to be repaired and retest, they needed to verify the serial number to see if they are retesting the device that failed, or they are doing an initial test of a new device for that to register cross connection. So that one is a business kind of a problem that we have with the plumbers. They want to make more money, so then they just replace the whole device. And the idea is for us in our training to the backflow tester, is that they should inform the backflow preventers owners that the devices can be repaired. Very unusual cases that the device is completely damaged for whatever reason and then must be replaced. But the reality is that most, and there's another issue, is the plumbers, when they come to test the device, to repair the device, the last job that they had was to replace a wax in a toilet bowl. So they come with their bucket and the screwdriver and a rag, and they open the device and they start to touch. And of course, if they're gonna do the repair, they change the module or change the disc or the ring, etc. And but unfortunately, they don't sanitize the tools. They don't sanitize their hands or even the rags. And of course, after they put all together and put the device back online, you don't know if the first to draw of water will be somebody that is going to prepare the formula for a baby. So it's a lot of people got sick and don't know why, and that one sometimes is the reason. So we have our bit concern about the repairing of the device, because the certified plumbers are responsible to install and repair devices located in domestic line, and the fire sprinkler feeder and contractor are responsible to install and repair devices on the fire protection lines. So, but that one is a concern.
That's great. Mitch, Bruce, or Mark, you want to add anything to that section?
I really don't. I like the way it was said already. If you start swapping those parts out, then you're assuming you know as much as the manufacturer does about the intricacies of those. Some of it may not be a big issue, but you just don't know. Some of it could be in their engineering. It could be very critical that it be to their specs. So
I agree with what Mark said. I really don't have anything to add here. I do think everything was covered very well.
Totally agree. The comment that Bill made in regards to OEM parts is imperative. We do know that there's some parts that are out there that don't meet that standard. And unfortunately, the backflow preventer tester gets an opportunity to go back to those assemblies because he tried to buy lesser parts, and they end up having to go back and fix them over again just for not using OEM parts.
Great. I had a quick example from my career just about that I wanted to share with everybody, and it's real short. We were providing maintenance for a building, and on the second floor of the building, they had a photo lab with an atmospheric vacuum breaker, of course, no valves downstream of it, and it had started leaking out of the top of it. So the maintenance person for this particular entity decided it would be okay to take the top of the vacuum breaker apart and put a 3/4 inch plug in it. And this is real world. This is what we see out there, right? So it wasn't until the drinking fountain water started smelling funny, because now we were getting photo lab equipment, chemicals back into our water supply that we wound up having to drain the building and flush it and put a bleach hold on it and sanitize and retest and do a bunch of stuff to get that building back up and running. But that's just one example from my career. I want to really open this up to the chat group now, and maybe while we're monitoring the chat, if any of the panelists have any final thoughts they would like to share, just grab the mic and start talking. Jim, do we have any questions in the chat that have come up? So there was a few things in the chat. There was one question from James here in the chat I'm seeing that says, in Colorado, we had questions about water supply lines to dental chairs. We consider them high hazard and require independent RPZs. What are your thoughts?
I can speak to that. When dental chairs first really got a hard look at was the potential of what is laying within the chair itself over a period of time, and they had discovered quite a bit of biofilm. Actually, what was interesting to me was there was a TV show at the time, 2020, that did a special that did a comparison out of a urinal and a toilet, the water that was in it, and what they found that was in the line that they used to wash your mouth out. And the water quality, believe it or not, was better in the urinal in the toilet than it was on that fill line after it set for a couple of days. So there is a mantle block on the chair that's supposed to keep all of that separated. It's always been a concern for the water purveyor. So a lot of the dentists in today's world also finally took that to heart and started putting in bottled water. So now they have a better quality of water, and they're doing something that's more in tune, and in most cases it already has fluoride in the water. So it's a way better mix. But in answer to his question, if they're still getting water from the water purveyor, isolating per chair, in most cases, the chairs can be comboed with a RP. But if you need to do individual isolation, by all means do it, or see if you can convince that dentist to convert to a bottled water system and then monitor them after that.
Great, thanks. I have another question. Talks about in restaurants, many owners clean their floors with high pressure spray hose. If a water hose is connected to a janitorial sink faucet, which has a vacuum breaker enough to protect the water main, or should there be a secondary check valve or some other device added? If it's enough, are there types that are better than others? So I'm assuming this to where we're hooking up the hose to the mop sink faucet to a power washer. That's the best I can equate this to. I hope that's what Carson and from Carson City to everybody.
This is Mitch here. I would add, I started to say something a little earlier when we were talking about the mop sinks. When my experiences are that typically those mop sinks are going to have the integral atmospheric vacuum breaker device installed inside the plumbing fixture. The design professionals do a good job. The plumbers do a great job connecting all of that. And then afterwards, you get the aftermarket chemical salesman to come in and connect. And there's really three installation guidelines for the AVB, the atmospheric vacuum breaker, and all is well when it's installed. However, typically a splitter is put on downstream, which has shutoff valves, and then it's connected to a a chemical dispensing system. And back to the original question here, the pressure uh, washer or machines downstream. It's very difficult to come up with an answer to this, and and this is just my opinion. It's difficult to come up with um, because most of the codes that are out there um, speak of the atmospheric vacuum breakers to protect the drinking water system. However, the uses downstream tend to violate those installation requirements, and I see this constantly and continuously, as I'm sure our other panelists do. And quite frankly, short of having a separate supply line for known violations of the AVB installation, I don't know what the solution is at this point. Well, I've had discussion with various state officials, plumbing officials, and it's really difficult to overcome, these installation requirements. Is a back pressure situation on an atmospheric vacuum breaker acceptable? Which I believe is kind of where this question was. The answer is no. Short of having a separate uh, supply with say an RP on it or a double check possibly, depending on the situation, I don't know how we can get around that.
I've got another
Well,
question that just came in from Dale Hall. And I think it may be related to something that Bill said earlier with post-carbonated drink machines and CO2. Is a backflow needed with a PEX piping at the carbonator?
Well, most codes, it's illegal to use copper downstream of the RP anyway on a carbonated beverage system. But I think the question would be, if the whole building is piped in PEX. It's a possibility. I don't know where they do in other states, but in Indiana, the move is toward PEX has already taken over the residential market and it's working on the commercial market to a degree. I would say yes, because the CO2 gas is more than just a pollutant into the system, even though you're not leaching copper. So I guess my opinion is just that, my opinion. I'm sure others might argue with me, but I would say it would be needed.
I'm going to
I
agree
agree
with
with Bill.
Bill's
Yeah.
opinion, because also in those components of a lot of that stuff, you're going to have those brass alloyed fittings, connectors, possibly things like that. So I would agree with him. Even though the piping is PEX, you're still going to have some of that brass alloy that carbonation could get exposed.
Great. And I can tell you that the Model International Plumbing Code is going to require cross connection control on all of those post-carbonated drink machines, as just in the model code. And I believe Massachusetts Plumbing Code, even though they're homegrown, Octavio, I believe they also require that in their model code.
Correct. Yeah, and regarding the cleaning product chemical dispensers, with the plumbing board, we do require them to have a dual check with an atmospheric vent from the sink, the janitor sink, to the chemical dispenser wall, and have a pressure relief valve also with that connection, because usually what the manufacturer does, they use a piece of garden hose with a repair kit for garden hoses and a Y. So they install the Y on the sink, then one leg of the Y goes to the device on the wall, and that one, that is basically their sales pitch, because it's so easy. You don't need the permit, you don't need the plumber to do the installation. We can do with a garden hose. And since we do have a dual check with atmospheric vent for garden hose, for hose usage, we can use that one. So it's, the two things, the pressure relief valve and the dual check. Because the problem is also with those chemical dispensers, some of them do have an air gap separation. But usually, because the water pressure, they spill, and they are so accessible to the people that use those type of equipment. So what they do, they open the equipment and use the duct tape and bypass the air gap and solve the problem to have water spill every time that they use the equipment. So we try to prevent those kinds of situations as much as possible. And since the non-residential facilities are required to be surveyed for cross-connection and resurvey, that one is what the water supplier must pay attention.
That's great. We're coming down. We've got about 2 minutes left, and I want to open it up to the floor of our panelists for any closing thoughts before we end this webinar today. I got a lot out of it personally, so I want to thank our panelists, and if you have any closing thoughts, I would appreciate it.
One thing I want to thank everybody that's on the panel. I think we've had some terrific subject matter experts here. I guess the one thing that comes to mind is no matter what part of the world you're in or what state you're in, and just do your absolute best to adhere to what the state rules are. And if the state rules aren't covering what you think needs to be covered, then become involved. Try your best to understand their thought process. So when it comes to backflow prevention and cross connection control, everyone ends up on the same page. And that seems to be a constant challenge no matter where we all go. But ultimately, if we get good rulemaking and good rules for these guys to follow that are out there testing these backflow assemblies, we have some really great success stories to pull from.
Hey, I will appreciate that comment. And also, I'd like to leave a suggestion. I'm first to apologize for what's happened with me. I don't know. It seems that my email address have changed, but that one is a long time ago. But seems that WebEx did accepted my new email address, despite I get the help from somebody from WebEx and also Richard. My suggestion is that maybe we can exchange our email addresses so we can look at the regulations and policies and programs around the country. I will appreciate that.
Excellent. Well, we're just about out of time, so I'd like to thank our sponsors this year for Building Safety Month. We have the American Gas Association, we have the American Concrete Institute, we have Luna, we have the National Multi-Housing Council. We also have the National Council of Architectural Registration of Boards. We have Simpson, Strong Tie, and State Farm. And I think our panelists said it really well, but I just want to reiterate the fact that thank you everybody for joining us today. I was truly impressed with the conversation from our panel of experts. And in closing, just please try to always remember to hire a licensed professional. Contact your local building department to obtain the required permits. By taking an active role in cross-connection control in our homes and businesses, we can all ensure that our water supply remains safe and potable. So thank you everybody for joining us, and enjoy the rest of your day. Have a good evening.
Thank you very much. Bye-bye. Thank you. And be well. Have a happy summer.
Thank you, everyone.
Thank you.